so now it's time for our last flowchart, and this one's going to be for all the hypothesis tests. And just like before, we've learned 5 of them, so we have to keep them all straight. Now the good news is that these ones take up their own pages, so we'll have an entire page to refer to in our exam notes packet. So this one, single proportion, was the first one we learned. That was in section 10.2. And then we learned a difference in 2 proportions. I'm actually going to skip and do the 2 proportion ones together. So the difference in 2 proportions. That was section 11.1. So those 2 are the proportion ones. One was from section 10.2, one was from section 11.1. And I didn't put it in here, but we should have a page number in here. So let's make a note of the page number. We'll just kind of put it here. Because of course, as always, our flowchart's really guiding us towards a particular page in our note packet. So you want to make a note of what page it is in your packet. So I can show you what they look like. And you can spot them yourself because it'll say the section number right at the top. So section 10.2 is this one. For me currently, this semester I'm recording this, it's page 238, but you have to fill in the page for your particular page. So that's 10.2, and then 11.1, it'll be a couple pages later. It'll say section 11.1 over here on the right, and it says 2 independent proportions. All right, well, there was one in between those 2 that we saw. There was the one that was for a single mean. That was section 10.3. And give yourself a page number for that one. And then we have 2 different ones down here. And this is where it gets a little tricky. This is the mean of matched pairs differences. This is the dependent sample one. As opposed to the independent sample one. Here, give yourself a page number for all of these. And this is the difference of 2 means. Very similar to the difference in 2 proportions, it's just its means instead. All right, so this was section 11.2, and this is section 11.3. And it'll say the titles right on the exam notes packet. So the single mean is right here, that's 10.3. Again, for me, it's currently page 239, but where it is for you, you have to look at your exam notes packet to find out. And then here's section 11.2, and here's section 11.3. It should be the last page of the exam notes packet. All right. Now, how are they different? Well, they're all very different. These 2 are proportion ones, so these kind of match each other a little bit. So they're going to be looking at proportions, percents, surveys and polls for one group. I'm going to have to fit that in here, for one group. Whereas this one is the same but for 2 groups. Let me write that up. All right, so this will be for one group, this will be for 2 groups. And I put in the hypotheses here, and I think what gets a little confusing is the subscripts. So when you see P0, it doesn't look any different as a student from P1 and P2, but they are different. This particular P1, let me highlight it in like pink or something. This will be a number from the context of the problem. A number will be given to you that you have to use. So it'll be P equals some number, right? So this will be a number. Whereas down here, they won't be numbers. They'll just be letters, right? P1 and P2 will stay in letter format. Right? No numbers. All right, now because they're all proportions, the quality for being normal when you run the test is very similar. So if I look at section 10.2, normal is n times p0 times q0 is greater than 10. It's right here. And then when I look at two proportions, it's p hats, but it's the same idea. So I'm going to write all of that in right there. There they are. Right there. So they look similar, right? N times p0 times q0 greater than 10 versus doing it twice. But this one allows you to use the p hats, whereas that one you have to use the ones from the null hypothesis, right? That's where the p0 comes from. It's the same number. So this same number right here is that right there. Now the technology for these are given in these packets. It tells you right here at the top, stat, proportion, stat 2 sample with summary, because of course this is 2 independent means, as opposed to stat, proportion, stat 1 sample with summary. So that'll go into the technology line here on the flowchart. So it'll be stat, proportion, stat 1 sample. Oop, I ran out of space, with summary. And this will be stat, proportion, stat 2 sample with summary. The proportion ones are always with summary, always, at least for our course. You technically can do them with data, but we've never dealt with proportion data like that. So just to highlight, this is singles. This is 2. 1, 2. This is for one group. This is for two groups. That's what makes them different from each other. But they're all proportions. So there'll be percents all over those problems. They'll be talking about a survey or a poll that they did, that kind of thing. So when you see that type of info, you know it's one of those two. As opposed to the bottom three. So the bottom three are all data, right? So they're all with data tables or averages, standard deviations are given, that kind of thing. So this will be the data are given for one group, right? Mean, average, data, standard deviation for one group. This will be for matched pairs group, and this will be for two groups. So if I wrote mean or average, right? Average is the same word as mean for us in these later chapters. Standard deviation or data table, right? Because you could have the mean and standard deviation given, or you could have a data table given for one group. Right? And then this, well, I'm going to skip that one because this one at the bottom is actually the same thing, but for two groups. The odd one out is actually the matched pairs, because matched pairs is, of course, dependent samples. So, and that makes it different than everything else we've ever done. So this is the average or the standard deviation. So it's means plural, averages plural. There's two of them. Standard deviations or data tables, but given for two groups. Two independent groups, two separate groups. Okay. So these two are actually very similar. This one in the middle, well, you can spot it if it's a matched pairs, right? So if it's a matched pairs data set, it'll usually be a dependent sample given. So if it's a matched pairs data set, that's the one. So if there's data, usually almost always it's a data table given for a dependent group. And again, usually the way we think of dependent groups are matched pairs. So if you're asked to run a test and it's a dependent group, this is the only one it could be, right? Whereas these are for one group, single, right? Two groups, independent, two groups. This one is dependent. This one's special, right? Matched pairs is special. Matched pairs is dependent. Okay, well, how does it vary in terms of what we do in StatCrunch? And how does normal vary? Well, actually, let me back up before I even do that. The way this will be, it'll be mean mu equal to mu 0. And much as before, mu 0 is going to be a number, right? Mu 0 is a number from the context of the problem. Right? It'll be a specific number. Whereas in these later ones, it'll be mu d equals 0. That is how the null hypothesis is written. Or mu 1 equal or minus, I say mu 1 equals mu 2. You could also write it as mu 1 minus mu 2 equals 0. I should add that here because this could be mu 1 minus mu 2 equals 0. And same thing with up here. This one could be P1 minus P2 equals 0, like that. In general, when we do them by hand, we write this equals piece, but StatCrunch in particular does this piece with the mu1 minus mu2 equals 0. They are equivalent, so it doesn't really make any difference. The odd ones out are actually these ones from chapter 10, where you have specific numbers that you have to look for in the problem, as opposed to the later chapter when you don't ever have to have numbers. This is just left as a letter. It just stays mu d, right? So this stays as letters. You don't find a number specifically. The number is 0, right? Same thing here, right? The mu1 and the mu2 just stay as letters, right? You never have specific numbers for them. All right, now let's think about the normal piece for them. So normal is not the same way for means as it is for proportions. For proportions, you have to do n times p times q is greater than 10. But for means, you need either n to be bigger than 30, or there needs to be a normal probability graph that you can kind of gauge normality from the linearness of the points on the graph. And it's same for both 11.1 and 11.2. 11.3 is a little weird because you have to do it twice. So that's that. So I'll write those in. So this is n greater than 30 or graph for section of 10.3. And then it's n greater than 30 or graph for section 11.2. But down here you have to do n1 greater than 30, n2 greater than 30, or graphs, plural, because there has to be more than one, because there are two separate groups here. Now, the technology piece for these is the same as it was for running confidence intervals. So this is stat, t-stat, one sample, because it's for one group. Down here, the bottom one is stat, t-stat, two samples. Although I think it actually says two sample, which is not good English. From there, you have to determine with data or with summary, just as we always have had to do in these last chapters. So data is when you have the full set of data with you. Summary is when you don't. And the weird one is actually this one. Because it's matched pairs, we do stat, t-stat, paired. Because it's matched pairs, we use paired. So keep in mind, the two up at the top, if I want to kind of segment them off here, these two are proportions. Right? Surveys and polls, that kind of thing. Right? So these two are proportions. That's why proportions and percents are flying. Down here, these ones from here below are means, right? They're all about means. So that can help sometimes with figuring out which one to use when. Sometimes it's for one group, sometimes it's for two separate groups, and sometimes it's for the differences between a matched pairs sample. Where matched pairs, of course, is one group measured twice.